Okay, we are doing the simulation of how old is the YMCA line dancing class. So, did y'all ever learn line dancing? Okay, fun fact. Back in elementary school, whenever I was in elementary school, it was part of the curriculum for PE. We learned line dancing. Yes? Y'all never learned line dancing? Did you?
I did. I was like 8. So
Yeah, okay, so you did. It was fun. My father-in-law was a PE coach, and he actually taught the line dancing, and he taught it at the rec center too. Like, this is kind of funny. All right, so are the ages of students in a line dancing class very spread out or close together? Mrs. Dobbs attended one when she was 16 and was a little surprised to find the ages. The line dancing class at the YMCA has eight students in it. Their ages are below. What do you notice about the ages right now?
They're old.
Yeah, they're old. Yeah, we got old people who enjoy line dancing. Maybe they learned it back in elementary also, and then they want to come back to it. And then what about Ms. Dobbs? How old is she?
16.
And she showed up to the line dancing class. How do you think she felt?
Very
Uncomfortable, a little out of place, So it says, calculate the mean and median for the set of data, and then we're going to compare them. So it's a small set of data. So we can find the mean. The mean is the average. And all we do is we add them up. So the sum of xi divided by n. And in your notes last night, I forgot to say what n was because I went through all the symbols. But n is just the number of pieces of data. So in this case, we have 8 pieces of data. So let's go ahead and add all these up and then divide by 8 to find the mean. And Desmos will do simple calculations for you too. All you got to do is just put the numbers in, plus, 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 plus. Or there's another way of doing it. I think we're going to do this other way real quick. I missed it. There we go. And if I want to find the sum, there's the option. Sum of n. I don't like that one. So I don't think it'll actually do that. So I have to add them up. Or I can type in mean. My pencil keeps on messing up. Mean of... It's a little harder to do on the iPad. There we go. So there's your mean. You added them up and divided by 8. What was the sum? Was it 102? Was it? Huh? 576. I don't know where I got 102. That was something else. Okay, and then that came out to 72. Okay, and then we need to find the median. You can list them all out, find the middle. Or we can make Desmos do it. I'm going to list them out in order. So start with 68, 68, 69, 70, 73, 74, 76, 78. And then we start marking them out. and that leaves us with 2 in the middle. How do you find the median whenever you have 2?
You add them together and then divide by 2.
So what do we get on the median?
71.5.
Yeah. So the mean and the median are really close to each other. So that also tells us that this data is probably going to be symmetric because they are really close together. So we also need to find the range. I took training this summer, and we went through an older test. And one of the questions just said, what is the range for this data? Show your work. So I just subtracted them out of my head and wrote range is 10. So then the next day when we came in and we were grading it, I would have gotten it wrong because I didn't show my work. Even though 78 minus 68, easy, just you write 10, like you're done. But whenever you are doing your AP test, they want you to show your work. Where did this come from? So they want you to show this, range equals max minus min, because where is it coming from? You're subtracting. The max is 78, the min is 68, so the range is 10. Yes?
Is our AP test like on a computer or is it?
The multiple choice is on computer, and then free response is handwritten.
Okay.
The questions will be on the computer, and then you write and turn in your booklet. And Desmos is available, and you'll also have a handheld calculator. Okay, so we have 1 and 2 answered. All right, step 3, or number 3. Finding range is helpful, but it does not tell us how spread out the data is between the minimum and maximum. How can we find the average distance of values from the mean? So complete the table. We have the values. They've already completed the first 4 for us. So let's write the other numbers. So we take the value that we have and we subtract the mean from it to see how far is it from the mean. That's what was done all above that. And so if it's negative, you write negative. If we were to add all these distances from the mean together, we would end up with probably 0 or close to 0. So we've got to do something different. We've got to square it, then add those, then find the average. And then we got to take the square root because we've got to get rid of the squared. So let's go ahead and write 1 squared is 1. Negative 4 squared is 16. Negative 3 squared is 9. 2 squared is 4. Then we add those up to find the sum of the distances from the mean squared. So add these up. $102. I knew I got 102 from something. The average distance from the mean squared. So now we want to take the average. So what do we need to do to find the average on that?
Divide by 8.
Yeah, divide by 8. Okay, so we're not quite there because we also need to take the square root. So we're going to come over here. We're going to take the square root of that. Was it 12.75? We had to square to get rid of the negative, so that's why we're taking the square root now, so we can get rid of the squared part. So that comes out to, what, 3.57. Okay, this is going to be called the population standard deviation. I'm going to just abbreviate SD. But whenever we are finding standard deviation, we are going to be doing usually our sample standard deviation. So here's the formula chart that you'll get. And the sample standard deviation is a little different. So we're going to find that. So number 4 says, look through our TI-84 one variable stats and record these two values. So you can do this in the calculator. So I'm going to show both ways. Let's go to stat, edit, put that data in. If you want to just do Desmos, that's fine too. Stat, edit, put the data in. And then we do one variable stats. So I'll show you where that is. Okay, so we'll hit stat again and go over to calc, and then number 1, one var stat, one variable stats, hit enter. And then that gives you some statistics from that one variable statistics. All right, so it says S sub x, that's the first one we'll look at. Then it says sigma x. So those are the two that we're gonna look at. So sigma is our population standard deviation. So let's write that here. This is our population SD. And then this one is our sample SD. This one is called sigma. I guess I really didn't. I already wrote that it was standard deviation. I'm going to take that off. Okay, and that was 3.57. We're going to go to 2 decimal places where we do standard deviation. And then S sub x is our sample standard deviation, and that's 3.82. So let's look at what Desmos gives us whenever we do the same thing. So, let me go to Desmos. So I already have my data. It will also give me my median. And then it'll give me my standard deviation. STDEV. And if you don't know what to put, you can go here to the keypad, go to functions, and then look at what's under statistics. See how it says mean, median, min, max, quartile, ST deviation P, that's for population. So we're just doing sample, so it'll actually give you both, which is great. And then the other one was the P. There we go. So it gives us both. Okay, so I want to talk about real quick how the sample standard deviation comes about. Instead of dividing by n whenever we did our formula, we are going to divide by n minus 1. So over here, we did 102 divided by 8 and then took the square root of that. To find your sample, you would do 102 divided by 7 and take the square root. The denominator is changed from n to n minus 1 for the sample standard deviation. So go ahead and do that real quick. And let's just check our work. Take the square root of 102 divided by 7. Did it come out to be 3.82? Okay. So that's the difference between the population and the sample. All right, number 5. So let's go back to this problem where there's older people at this dance practice, line dancing practice, and Miss Dobbs shows up. She's 16, and we want to compare. So we forgot to add Miss Dobbs, add her to the data set, calculate the new mean, median, standard deviation using calculator or Desmos, and then we're going to talk about how they compare. So you can go back to your calculator, or remember we did this into Desmos, so I can just go here and go to the end. I'm going to hit comma 16. And then it changes every value underneath that because I changed the original set. So that to me makes Desmos like easier to use because I can just put that in and it automatically changes that. In the calculator, I would need to go to list, put 16 down at the bottom, and then go back to edit, calculate one variable statistics. Okay, so let's write down those values. The new mean is 65.77. The new median is 70. The new standard deviation, we're going to use, let's use the sample. So 19 points, we'll do sample. 19 point, what is it? 01, thank you, 01. Okay, so how do they compare to the original measures and why do you think that is? So the means, let's just compare the mean. The mean went from 72 to 65.77. So what happened to the mean? It dropped. It dropped because of what? That outlier at 16. Ms. Dobbs is 16 compared to everybody else who is way older. So this one, mean dropped because of outlier at 16. What about the median? Median 70, but it was 71.5. Did the median change that much? Didn't change much. And then what about standard deviation? Big change, little change. Yeah. Okay, so we got to talk about why that is. So on your notes, talked about resistant and non-resistant measures. So the ones that don't change much are resistant to outliers. So the median is resistant. Because the way we find the median is we just go from outside and work our way in and find that middle. So it's not affected that much by outliers. But the mean, we have to use that outlier in the formula. Standard deviation, that outlier is also used in the formula. So this one and this one are non-resistant. So they're affected by the outliers. And then something else about the mean is the mean chases the tail, but the mean also chases the outlier. So if the outlier is high, then your mean is going to go higher. If your outlier is lower, your mean is going to go lower. Mean chases the tail. Okay, let's look at some summaries on the next page. So we have two measures of center, mean and median. The mean is the average, where you just add them up and divide by the number of add-ins. That's the formula. If they ask you to show your work, then you have to show your work. If they just ask what is the mean, you don't have to show your work. Median is the middle value. So middle value of odd or average of two middle numbers if it's even. So this is measures of center. Okay, measures of variability. Variability is also called spread. Remember SOX? It's the last S. So we would find out how spread apart the data is. So IQR is one measure. Q3 minus Q1. Got to find your quartiles and then subtract them. Range is another, where you just do max minus min. SD is our standard deviation. We are going to use a formula. You can do population or sample, and it'll usually tell you. Most of the time, I believe we're going to use the sample SD. So whenever you're describing a data set, here is a good sentence stem to describe standard deviation. Okay, so we're going to fill in the blank with information from the problem. So you start out with the context, so whatever the context is, the points per game, the ages in the dance class, whatever the context is. The context varies by standard deviation, whatever your SD is, from the mean of, you write down what the mean is, the actual values. Make sure you include units. And then variance is whatever the standard deviation is squared. Might be sigma squared for population. Okay, and then outlier, skew effect on the center and variability. So the mean and the standard deviation are greatly affected by outliers. If something is affected by outliers, they are non-resistant. So if you have outliers or if your data is skewed, you don't want to use those. Instead, you want to use the IQR and the median. So IQR is for variability, median is for center. If it's symmetric, then it's totally fine to use the mean and standard deviation. Okay, so you're going to go ahead and do the application problem, and then we'll come back and see how you did. Okay, so here are the results for the mean and median. And the data was graphed on a bar graph, and it's skewed left. So when it is skewed, you do not want to use anything that is non-resistant. You want to use resistant measures. So our resistant measure for center is the median. So we would use the median because the data is skewed left. Any variation of that is fine. You could say because it's resistant or because it's, I wouldn't use the mean. You know, there's lots of different ways to answer that. Then number 4, I would want you to use that sentence stem that we have up top. So the annual rainfall for these 9 cities typically varies by 15.52 inches from the mean of 34.94 inches. So don't forget to put your units of measure, because that's part of context, is using those units of measure.